everyone, my name is Kenshin Kyu and today I am going to teach you how to solve problem solving. A lot of students are struggling when it comes to problem solvings and I am here to teach you how to solve problem solvings. And I will solve 5 problems that you can familiar with it and it will make your problem solving skills improve. So, let's get right to the 5 questions. So here is problem number 1. 5 times a number increased by 7 is equal to 47. What is the number? So here is my solution. Let's go for the first solution. According to the problem, 5 times the number increased by 7 equals 47. So 5 times 7 equals 47. On a second solution, first subtract 7 both sides of the equation to get rid of the constant term on the left side. So 5 times plus 7 minus 7 equals 47 minus 7. Now, so in the third solution, bring down 5x equals the result of the second solution, which is 40. Divide both sides by 5. 5x divided by 5 equals 40 divided by 5 is equals to x equals 8. Let's proceed to the second problem. So here's the second problem. The sum of two consecutive integers is 65. Find two numbers. Let's first find the integer, which is x. Since the integers are consecutive, the next integer is x plus 1. So x plus 1, according to the problem, the sum of these two integers is 65. So x plus 1 equals 65. Solve this term here, x plus x is equals to 2x plus 1 equals 65. Subtract from both sides to get rid of the constant term on the left side. So 2x plus 1 minus 1 equals 65 minus 1. Divide both sides by 2, and since the next integer is x plus 1, the result of this term here is here, so that is not yet the final answer. Therefore, the two consecutive integers are 32 and 33. So how did I get the 33 answer? Since the integer is x plus 1, 32 plus 1 is equals to 33. So problem number 3, the sum of 3 consecutive integers is 42. Find 3 numbers. Let the first integer be x. Since the integers are x plus 1 and x plus 2, according to the problem, the sum of these 3 integers is 42. X plus times x plus 1 plus times x plus 2 is equals to 42. Combine the like terms. X plus 1 plus x plus 2 is equals to 3x plus 3x. To get the 3x, just simply add x plus 1 equals 3x. X plus 2 is also equals to 3x. Subtract both sides to get rid of the constant term on the left side. 3x plus 3 minus 3 equals 42 minus 3. Then bring down 3x and the answer of 42 equals 3 is 39. So and divide both sides by 3. The next two integers are x are plus 1 and x plus 2. So after this is not yet the final answer. So you have to add the answer here to the integer. So 1 plus 13 is equals to 14 and the other integer is 2 plus 13 equals 15. And that is your answer. So in our fourth problem, the sum of two consecutive even integers is 94. Find the number. First even integer be x. Since the integers are consecutive and even, the rest integer is x plus 2. According to the problem, the sum of these two integers, x is 94. So the sum of these two integers is 94. X plus 2 is equals to 94. And so x plus times x plus 2 is equals to 94. Combine like terms, x plus 2. Then get the answer of this, get the result of this term right here. So x plus x is equal to x plus 2. Bring down 2 is equals to 94. Subtract 2 from both sides to get rid of the constant term on the left side. So 2x plus 2 minus 2 equals 94 minus 2. This is your answer. The result of this term right here is this one. This will be your answer. So 2x equals 92. because you subtracted 94 and 2. Divide both sides by 2, and the result is x minus 46. Simplifying this, we find x minus 46, the result of the result of the answer here. Since the even integers is x plus 2, 46 plus 2 is equals to 48. Therefore, the two consecutive even integers are 46 and 48. And this is our fifth problem. 9 times a number decreased by 5 is equal to 49. What is the number? According to the problem, 9 times the number decreased by 5 equals 49. To solve for x, first add 5 to get rid of the constant term on the left side. So, 9x minus 5 plus 5 equals 49 plus 5. Simplifying both sides, we get 9x equals 54. Then, we divide both sides by 9 to isolate 8x. So, 9x equals 54 divided by 9. Simplifying this, we get x equals 6. We're going to proceed to our second topic, which is circuit diagram and Euler diagram. In this topic, we're going to look for a valid argument on both topics, which is the circuit diagram. You are going to make a truth table whether if your switch is a true or false, which means that your switch will be on or it can be switched to off. In Euler diagram, we're going to make an example on how you make or compare an argument or make an argument on our second topic. We are going to talk about the truth table. To create a truth table for the impression of R or P and Q, R or negation P, we need to list all possible truth values for the variables of R, P, and Q. Here are the step-by-step process. List all possible combinations of truth values for R and P. For P and Q, there are constant given. So, on P there are 4 T and 4 Fs. On Q there are 2 T's and 2 F's on each line, and R is 4 T's and 4 F's. To calculate the intermediate impressions, evaluate the final impression R or P and Q R or negation P for each combination. Each row in the truth table shows whether the expression of R or P and Q and R or negation P is true or false for a given combination of truth values for R, P, and Q. So to determine here, to find the T, you have to compare P and R. If there are 2 T's, you will immediately put a T. If there are F and T, the answer will also be T. If both P and R has an F, the answer will also be F. To find the answer of negation P, you have to answer the opposite of your P. If your answer in the P column is T, then your answer in the negation P column will be F. So T, F, T, F, and T, F. On the fifth column, R or negation P, you will determine which is true or false. You will compare R and negation P. So R is T, then F is equal to T, T, F is equals to F. How do we get the F? Because in the negation P, if there's an F, the answer will be immediately F. So T, F, T, T, F, and F, and T, T, and so on. On the final formula, on the last column, you will combine all formula on your circuit diagram. So you have to compare these columns, the Q, the R and or P, R or negation P. So T, they have T, 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 so the answer will be T. Q will be your answer, or to find the T or F in this column, you have to compare R or P and Q. So both columns have T, so you will put T. Over here next is R or negation P. So R negation P has F and Q, so it's F. Then another one is R or P and you have to compare. There's a T, so you will put T. R
or negation P, there's F, so you have to put F. R or P and Q, you have to compare. There's both F's, so you will put F. And R or negation P, compare. R negation P, there's a F, so you will answer is F. And you will do the same thing as I did. So in conclusion, the expression of R or P and Q and R or negation P is true if and only if Q is true and R is true, regardless of P or P is false. This means that the overall expression to be true, Q must always be true, either R must be true, or if R is false, then P must be false. So this is your switch here, and this is your truth table.
Euler diagram is we're going to make a diagram on if your diagram is whether valid or invalid. There are four Euler diagrams. There's all P's are Q's, some P's are Q's, no P's and no Q's, and some P's are not Q's.
On the next topic is Euler diagram. On the first diagram, we are going to make an example of all P's are Q's. Here's my example of this first diagram. All Hollywood actors are rich. Johnny Depp is an actor, therefore Johnny Depp is rich. Hollywood actors are your P, and rich is your Q's. Johnny Depp here is the subject you are referring to. So he's a variable. Johnny Depp is C. You make a circle, then outside is A, Hollywood actors, and inside the circle is a rich, which is the Q, and inside of the small circle is the variable you were referring to, so Johnny Depp. So you put, why is there a point here is to determine which subject you were referring to. So Johnny Depp is rich, and all Hollywood actors are rich. On the second diagram, some P's are Q's. Some actors are American, some Europeans are actors. So on both diagram, you put the dot on the middle because on the either side of the diagram, P is talking about some actors are Americans, and on the Q side, some Europeans are actors. Therefore, both P and Q are actors that has Americans and Europeans, and no P's and Q's. No Europeans are good looking, no models are good looking. Your P is no Europeans are good looking, and your Q is no models are good looking. Some P's are not Q's. You have to make an example which that follows on the diagram. So some P's are not Q's. So some cats are orange, some orange are not cats. So P is your some cats are orange. You put the dot because you were referring to the P on the diagram. So some orange are not cats, then Q, then that is your Q.
On our last topic, we are going to talk about the validity of an argument. There are four kinds of arguments, so I'm going to talk about direct reasoning. I'm going to teach you how to make an example about direct reasoning. Let's get to it. So this is an example of a direct reasoning. This is the formula of direct reasoning. P, then Q, Q, therefore P. So this is my statement. If a person is a gamer, then they are smart. This person is a gamer. Therefore, this person is smart. So, if we generalize this statement, not all gamers are smart. Therefore, this statement over here is invalid. Why? Because not a single person, a gamer, for example, are not smart. There are other gamers that are smart, but most of them are not really. So, this is how to identify which P and Q. This is your P. If a person is a gamer, then your Q, then they are smart. Following the next formula, this is your Q. You copy this one, so you make this into a formal form. This person is a gamer. Therefore, for the conclusion, this person is smart. So this is direct reasoning.